Alright, so in this problem I have m minus n squared is equal to m squared minus n squared. So to solve this problem, I'm going to first start by rewriting m minus n squared. And I'm going to rewrite this to m minus n times m minus n. Now from here, I'm going to expand this by multiplying these two. So to multiply these two, I'm going to first start by distributing the m. M times m is m squared. M times negative n is negative mn. Now I'm going to distribute the negative n. Negative n times m is negative mn. And negative n times negative n is positive n squared. So I have this is equal to m squared minus n squared. Now, I can do a few things here. I can first start by subtracting m squared on both sides, so this way these two m squares cancel out. And now I'll be left with negative mn minus mn plus n squared is equal to negative n squared. Now negative mn minus negative mn is equal to negative 2mn. And then now if I subtract n squared on both sides, these two cancel out and I get negative 2n squared. Now from here, I can divide both sides by negative 2. So then these two negative 2's cancel out, these two negative 2's cancel out, and I'm simply left with mn is equal to n squared. Now from here, I'm going to subtract mn on both sides. So then these two cancel out, and I get n squared minus mn is equal to 0. Now the greatest common factor in n squared minus mn is n. So if I factor out n, I get n times n minus m is equal to 0. So now this gives me two equations. I get n is equal to 0, which is already a solution, and I also get n minus m is equal to 0. Now, going back to our original equation, we have m minus n squared is equal to m squared minus n squared. If n equals 0, I get m minus 0 squared is equal to m squared minus 0 squared, which turns into m squared is equal to m squared, meaning m can really equal any number. If m equals 5, then I have 5 squared is equal to 5 squared. If m equals 100, I get 100 squared is equal to 100 squared. So m can equal any number if n is 0. Now for here, I have n minus m equals 0. So if I add m on both sides, I get n is equal to m. Now, if I put this back into my regular equation, I have m minus n squared is equal to m squared minus n squared, and I'm gonna rewrite n as m because they're both equal to each other. So now I have m minus m squared is equal to m squared minus m squared. M minus m is 0, so I have 0 is equal to 0. And this means that they're both equal to 0. So, now going back, what I'm going to do is do a different method to solve this problem. So method 2 is, first let's rewrite the equation. We have m minus n squared is equal to m squared minus n squared. And now this time, I'm going to again expand m minus n squared to m minus n times m minus n. And now from here, I'm going to rewrite m squared minus n squared as m plus n times m minus n. Because if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So now, as you see, we can simply divide both sides by m minus n, cancel these two out. So now I'll be left with m minus n is equal to m plus n. Meaning, if I subtract m on both sides, I get negative n is equal to positive n. If I add n on both sides, I get 2n is equal to 0, meaning n is also equal to 0. And if n equals 0, then remember how we already tried this out, m is also equal to 0. So these are my two solutions to this equation. Alright, so in this problem, I have 4 to the power of x plus 6 to the power of x is equal to 9 to the power of x. So to solve this, I'm going to divide both sides by 4 to the power of x. So I get 4 to the power of x over 4 to the power of x plus 6 to the power of x over 4 to the power of x is equal to 9 to the power of x over 4 to the power of x. Now, 4 to the power of x and 4 to the power of x cancel out, so I get 1 plus 6 to the power of x over 4 to the power of x is equal to 9 to the power of x over 4 to the power of x. And if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So in this case, 6 to the power of x over 4 to the power of x is going to equal 6 over 4 to the power of x. And 9 to the power of x over 4 to the power of x is going to equal 9 over 4 to the power of x. Now I can simplify these fractions. So 6 over 4 is equal to 3 over 2. And 9 over 4 I'm going to rewrite as 3 squared over 2 squared. And I can actually use this property again for 3 squared over 2 squared. So that's going to equal 3 over 2 squared to the power of x. And if I have something in the form a to the power of m over a to the power of n, this is the same thing as a to the power of n to the power of m. So this can equal 1 plus 3 over 2 to the power of x, which is equal to 3 over 2 to the power of x to the power of 2. Now I'm going to let 3 over 2 to the power of x equal to the variable y. So I get 1 plus y is equal to y squared. And if I subtract y minus 1 on both sides, these 4 cancel out, and I get y squared minus y minus 1 is equal to 0. Now, to solve this equation, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get y is equal to negative of negative 1 plus or minus the square root of b squared minus 4ac. So negative 1 squared, which is 1, minus 4 times a, which is 1, times c, which is negative 1, all over 2a, so 2 times 1. Now this is equal to positive 1 plus or minus square root of 1 plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So y is equal to 1 plus or minus the square root of 5 over 2. However, we're not done yet because we're not solving for y, we're solving for x. And remember how we let 3 over 2 to the power of x equal to y. So this gives me two equations. I have 3 over 2 to the power of x is equal to 1 plus the square root of 5 over 2, as well as 3 over 2 to the power of x is equal to 1 minus the square root of 5 over 2. Now to actually start, we can already cancel out one of these equations, which is the right-hand one, because 1 minus the square root of 5 is going to be a negative number, and you can't take the power of a positive number and make it equal a negative number. So this equation wouldn't even work. So the only equation I have left is 3 over 2 to the power of x is equal to 1 plus the square root of 5 over 2. And to solve this, I'm going to take the log on both sides. So I have log 3 over 2 to the power of x is equal to log 1 plus the square root of 5 over 2. So now this turns into x times log 3 over 2 is equal to log 1 plus the square root of 5 over 2. And now if I divide both sides by log 3 over 2, I get x is equal to log 1 plus the square root of 5 over 2 over log 3 over 2.